Today, in our second section of Unit 2, we're going to review solving and checking multi-step equations. So here's an example of an equation on the slide, and we'll be talking about how to solve these. We're going to start with this kind of a relatively simple two-step, and then I'm going to step into real-world applications of a two-step. Then we'll start adding some multi-layers to it. But everything that we do today, again, you have probably seen before. Pay careful attention to the standards as we go through. Okay, so before we start, let's just talk about a little vocabulary. So what is something that shows that two expressions are equal? We actually have talked about this word before in class. Did you remember that it's an equation? Now, what is the word that goes with finding the value or values of a variable or variables that make an equation true? And I'll give you a clue. It is S, starting with S, to solve an equation. And that's what we're going to be working with today. Notice there's values and variables, like there can be more than one. So as we go through Algebra 1, there's not always going to be just one right answer. Any value or values that make an equation true is called a solution, or obviously if there's multiple, it would be solutions. And operations that undo each other are called inverse operations or opposite operations. And if you have two equations that come out with the same solution, they are called equivalent equations. So today we're going to be solving equations. We're going to get our solution by doing inverse operations, and we're also going to check our answers. That's the cool thing about solving equations, is you can actually check your answer to make sure you have it correct. So we're going to just start with a basic two-step equation, but the one that I put here is one that students often make a mistake solving. So, in a two-step equation, basically we're going to get our eye off the variable. We're not going to be looking at that. We're going to be looking at this number to move it to the other side. Basically, we want to solve this equation. What value of h will, when we multiply by -6 and 5 minus that product, what will give us a 41? Now, I know lots of times when you're looking at two-step equations, you can kind of already see the answer, but I need you to show every step. That's what this unit is about. And of course, they're going to get far more complicated than this. So when we're solving this two-step equation, the first thing is people will often make a mistake and think that the 5 is being subtracted. Now, if you look in front of the 5, the coefficient is a positive here. I mean, not coefficient, but the sign is a positive. It's a positive 5. Subtraction does not go right to left. So in order to move that 5 to the opposite side as we try to solve for h, we would not be adding 5. We would be subtracting 5. And one of the ways to see that is if you change that minus to plus and negative. So some of you like to keep it as a minus, some like to change it to plus and negative. But when you do change it to plus and negative, you can see that that 5 is positive. So in order to get our zero pair, we would use the inverse operation of subtracting 5. Now on the left, 41 minus 5 is going to give us 36. And on the right, this is going to give us 0 plus -6h. And now we have -6h to contend with. The next step is to say, how would we undo this -6? What's happening? Now remember that the fact that there's no operation symbol between the -6 and the h means it's the invisible dot, the invisible multiplication. And the opposite, the inverse operation of multiplying, would be dividing. And if we do it to one side of the equation, we have to do it to the other side of the equation so that it stays in balance. So we're going to divide both sides by -6. Now, I'm going to tell you right now, a common mistake would be to what I call cut the arm off the number and just divide by 6. That is not the number 6. It is being multiplied by -6. So you need to make sure that that -6 goes along for the ride. 36 divided by -6, again, a positive divided by a negative would be a -6. And we believe that the only number that will be able to be substituted for h in this original equation is -6. So we are going to check our answer. You will always, must always check your answer in the original. Do not check it in anything that you have done math to, because if you made a mistake, you won't catch it. So in order to get credit for a check, it must go in the original equation, which is this guy up here. So you'll notice that I rewrote the original equation. It is okay if you go right to here, this second step. I brought this down just to make sure I told you to make sure you put it in the original. I know some teachers before might have said you have to write this first. I am okay with you going right to here. Now you're going to remember that this 6 is a negative. Remember, if somebody asks me, Mrs. Woodruff, is this a minus or a negative? I say yes. Okay, right? It's both, but this is a negative times a negative, which is going to give us a plus, and we can see that this is equal. I just reminded myself of another thing. I am also okay that when you're looking at this equation, if you want to just write the negative, divide by -6 underneath. In other words, if this step was missing here, I would be okay. And I know in previous years, sometimes you've been asked to write it again. But we'll get the hang of it. Just trying to save you a little bit of time. Okay, so we're going to take a moment and get off of the just skills and talk about where this gets used. And we're going to do a real world application. Now, this is where I really need you to pay attention to the fact that there's sort of a standard here all the way through the year. When we are doing a real world applications, these are the 5 steps that I would expect you to do. Whether I ask you in the problem to make sure you do these 5 things or not, they are expected to happen. So the first thing in this case is we are going to define a variable. What is the unknown value? We've talked about that in Unit 1. And you look to the question to figure out what is that missing piece of information. You're then going to write an equation using the numbers that are in the problem, not doing math in your head. You're going to use all the numbers in the problem. You're going to switch those words to operations, make an equation. The third step is going to be to solve that equation like we just did in the previous slide, showing all your steps. The fourth step is to check your solution like we just did. And the fifth step is to actually answer the question. That often entails making sure you have your units, but in future units, you really have to make sure that you answered the correct question. And we will already be talking about that in just a few sections down the road. So let's look at a word problem, or I like to call them application problems. Let's say you are making a 330-mile trip and you have already traveled 165 miles. If you are driving at the average speed of 55 miles per hour, how much more time do you have remaining for your trip? Now, if you're right now not sure where to begin, read your question. How much more time? And in this case, the time is hours. Your unknown is how many more hours remain in the trip. There is your variable. So the question will point you in the direction of where to start. Now you're going to come up here and you're going to grab these numbers and somehow get an equation with this single unknown. So if you think about a trip, basically there's the miles you've already traveled and the miles you need to travel need to combine up to sort of this total. There's usually a total in there. And in this case, it is the 330 miles. That's our total. Now, 165 are kind of already in the bag. They've already happened. And then there's going to be a remaining part of the trip. Well, the remaining part of the trip is going to happen with this 55 miles per hour. So for every hour you travel going forward, every hour you travel, you're going to add 55 miles to this total. So if you kind of look at this equation, there's your total. That's what's already happened. That's what's going to happen. And now we're ready to solve. Now, here's the good thing about application problems is they often don't involve negatives unless you're talking about things like going underwater, losing yards in a football game, or losing money, but most of the times, or below zero temperatures. most of the times they tend to stay positive, which makes the equations easier to solve. So once again, the first thing we're going to do is not touch that variable, and the opposite of adding 165 would be to subtract 165, keeping the equation in balance by showing it on both sides. This creates a zero pair on the right, leaving just the 55t, and 330 minus 165 on the left is actually 165 as well. Now to get rid of, or move, I should say, do the opposite operation of multiplying by 55. We're going to divide by 55. I just noticed my little lines are missing there. So, you should have kind of a line here like that, okay? And then if we take 165 divided by 55, it would be 3. So step 1, we defined our variable. Step 2, we wrote an equation using all the numbers and the variable we just defined. We solve our equation. Now we're going to check our answer. We're going to put that 3 back in the original equation. We're not going to put it in the middle, back in the original. We're going to check the math. We're going to take 55 times 3. We're going to add it to the 165, and sure enough, it equals 330. Now you don't just stop here, because what I would say is 3 what? 3 giraffes, 3 marshmallows, 3 what? Answer the question. And right up here, this is where your units help you guys. It's going to be 3 hours. So in 3 hours, you should be at your destination. So when you're doing an application problem going forward, you should always define your variable, or later on it will be multiple variables. You're going to write an equation where you haven't done math in your head. You're using the numbers that are there. You solve that equation, you check it, and then you make sure you answer the question by putting your units in. And later on, you got to make sure you're answering the correct question. Okay, let's get back to some basic solving, though, for the rest of this video. So we're going to talk about like terms, distributive property, and combining both. Those are the multi-steps. So this one I kind of have done out for you. So when we look at like terms, we have 3 this time. So if we look at 3 terms, it's not a 2-step. Something else has to happen first. So you're looking for the like terms to join up. We did this in our arithmetic sequences when we were simplifying the rule. We looked, there were 3 things there. We had to combine up the constants. Well, here they're actually variables. So 3x and a negative 4x will become a negative 1x. And now we're right back to a 2-step where we're going to undo the constant first. We're going to subtract 6 from both sides and then divide by negative 1. Don't forget, don't cut the arm off the number, and we should get 8. Now notice that I'm not putting that 8 into this equation. It's always back in the original. So 3 times 8 and 4 times 8, and I have to take 24 minus 32 and then add 6 using my order of operations. So you should multiply before you subtract or add, and there is a good check, showing it at the bottom that the left-hand side is in balance with the right-hand side. Now, another operation you would have learned back in, even earlier than 7th grade, but we did do these equations last year, is distributive property. And the way you know that is you see those parentheses. And again, we kind of did a quick little hit on this when we were simplifying our arithmetic and -1 rules. So you're going to take that 6 out in front. You're going to multiply it by both members of the group. So 6 times t plus 6 times 5 is 30. And I am absolutely okay if you go right to this step. You don't have to write 6 times 5 and then another step. Now it's back to a 2-step equation. And the opposite of adding 30 would be to subtract 30. And the opposite of multiplying by 6 would be divide by 6. And I think that the only number that I can replace for the t is negative 11. I'm going to remind you before I talk about a very important thing on a distributive property check that everybody in the class, I have never had a year where by the end of the year, you will forget to multiply. Instead of putting 30 here, they will put a 5. And the reason I am bringing that up is that if your check doesn't work, look there first. That might be the oops that you did. I call it joining the forgetting to multiply the second piece of the distributive property club. And already we had a couple people on our first quiz join in on that. So hopefully all of you will hear that, and this will be the year that it doesn't happen to everybody. We will see. All right, so when I go to check that, I'm going to put it in the original with the parentheses, and this is where I really need you to listen. You do not do distributive property in a check. We never do distributive property in a check, and here is why. If you made a mistake up here, you'll make the same mistake in the check and you won't catch it. So in the check, you are not, N-O-T, not going to take 6 times negative 11 plus 6 times 5. You are always going to use PEMDAS, order of operations, in your check. Forget you ever knew the distributive property. So you're going to go into the parentheses, and 11 plus 5 is negative 6, and then you multiply it, and you get a good result. To be honest, PEMDAS is actually easier. And like I said, if you forget to distribute to the second piece here, guess what you're going to do down here, and you won't catch the mistake. No distributive property in your checks. You will not get credit for the check if you do that. So here is your chance. So I am going to have you pause the video. The one on the left is a combining like terms. The one on the right is a distributive property. And when you are ready, come on back. Okay, so I'm going to start kind of at the bottom here. Oops, I thought I was going to start at the bottom. Let me go down there and get that guy. There we go. So did you get x equals 7? And did you over here get x equals negative 1? Now, if that's all that you have on your paper, that's great, but you're missing all the steps that will give you the other points. So the first point would be to combine like terms. So if this is on your paper, you kind of just gained a point. So x plus 3x would be 5x, and 2 take away 6 would be negative 4. And here we are at our two-step equation. We're going to add 4 to both sides. And if you did that, you just got the second point. Then you're going to divide by 5. You just got the third point. You got a good answer. You just got the fourth point. And did you do a good check? So if you look, you should have put in the original, not in here. Don't be lazy, people. So put that 7 in here and make sure you do the PEMDAS. So you should have multiplied. And then, yes, I'm okay if you kind of add them all together, which you'll see me doing there, and subtract 6. So 1 point for combining like terms. First step, second step, good answer, good check. This is a 5-point problem. If you only have the answer, you got 1 out of 5 points. Okay, the next one, we're going to do our distributive property, negative 2 times x and negative 2 times a negative 3. Do you have negative 2x plus 6? Did you goof up back here? Careful. Now we're at a 2-step, so you subtract your 6. You get negative 2x equals positive 2. Divide by negative 2. Don't cut the arm off the number. Answer would be negative 1. You're going to put that back in the parentheses. And you are not going to do distributive property. You're going to do order of operations. So you should have negative 2 times negative 4. And boom, there you are. So good distributive property. It's a point. Sometimes can actually be 2 because of the 2 pieces. It depends on what we're doing. First step, second step, good answer, good check, not using distributive property. Okay, so let's just do a little bit of a combo. And before we go there, this is what we kind of call the map. It's sort of, you have to do these things in order to kind of make sure that you're solving your equations correctly. And you're going to notice there's 2 pieces missing. They will come in lessons down the road. So if you are a person that likes to change your subtractions to plus and negative, you want to do that right off the bat. Step 1 is not mandatory. Some people see it one way, some people see it the other, but if you are going to make those that change, you need to do it right up front. The next thing you're going to look for is parentheses. You're going to use the distributive property to clear those parentheses, remembering to multiply by the second piece. There will be another thing to look for. We're not quite there yet. The next thing you do is to combine like terms. So you would never try to combine like terms through the parentheses before distributive property. That's why that has to happen first. Once you've combined your like terms on the same side of each side of the equation, then it'll either be a 2-step or sometimes you'll get lucky and there'll only be 1 step. And don't forget to check your solution in the original equation using order of operations, PEMDAS. Okay, so let's do this one together and then I'll leave you with one to do yourself. Okay, so number 1, If you like to change that to plus and negative, that would be the first thing. And notice I did it here. Again, you do not have to do that step. Second thing would be to clear the distributive property. And watch right there, right? That's where you're going to oops potentially. We're now looking for like terms. I got 3x's here and x there. You could commute these to have them right next to each other. If you are able to do that without writing that step, if you can do this, you're good with me. Now, to make a zero pair, I'm going to have to add 3. I need a -3 and a +3. So I will have 4x equals 8. I'm going to divide both sides by 4 to undo the multiplication, and my answer is x equals 2. So these are sort of the steps. You change your subtractions if you want to. Must do that distributive property before the combining of like terms, and then we solve the two-step equation. When I go to check it, that 2 is going right up in the original problem. And I am okay, actually, if you write this step and not this one in the check. You can go right into the substitution. I often do this on the slide just so if people are going, where would she get that from? It's the original problem. We're going to do the parentheses of PEMDAS, so 2 minus 1, that's pretty easy. I'm going to multiply before I add, so 3, and 3 plus 2 is 5. How easy could that be, folks? Okay, your turn, last one. So if you could, you're going to pause the video and you are going to show all the steps. They are each worth points. So a final answer is not going to get you all the points. So pause the video, do your steps, do a good check, come back, we'll see how you did. Okay, first step. If you want to change the minus, oh, by the way, the t was kind of missing a coefficient. That's the invisible 1. So you can slide that 1 in. And if you want to change the minus to plus and negative, you can. Now I'm going to give you a piece of advice. If you're finding that you're messing up the distributive property signs, try changing the minuses to plus and negative, and that could help you. So -3 times 5 and -3 times -1t. So there's the -15 plus 3 plus 8t. So if you kind of messed this up and you left that as a minus, try changing it to plus and negative, and that could help visually you see what's going on. We're going to combine like terms next, which will give us 11t. And now we're not going to touch the 11t. We got to make a zero pair out here. So with that -15, I actually need a +15. I got to make a 0. That will give me 11t equals 33. I'm going to divide by 11, and I get a 3. Now, I need to caution you. I'm keeping things kind of nice, and all the answers are integers right now. Life rarely gives you nice numbers. So as we move into applications and down the road, we're going to start seeing our decimals and fractions come in. But today, we're just making sure we get our solving equation legs back under us. Okay, I'm going to put that 3 back in the original. It's got to go in 2 spots. I'm going to do the parentheses first. No distributive property. I'm going to multiply. I guess I multiplied that one ahead of time, right? Oops. It's okay. And then I'm going to add. And there is a good check. My answer is t equals 3. So guys, today we reviewed solving multi-step equations. We started with a 2-step, especially one with the minus with the variable behind. That can be kind of one that people oops on. We talked about the 5 steps of an application where you need to define your variable or variables. You need to write an equation using the numbers in the problem, not doing the math in your head ahead of time. You're going to solve it showing the steps, check your answer, and then make sure you're answering the question that was asked and also putting your units in. We then went on to add like terms, distributive property, and both, showing all the appropriate steps. The only thing I can think of is, again, with a check, we don't use distributive property in a check. So it's your turn to practice. I'm going to think that this will come along pretty easily. The next step, we're going to insert some fractions and decimals in there, but I'm going to teach you how to get rid of them, how to clear them. People often kind of balk at the beginning, and then they learn to absolutely love it. So I hope you have a great day, guys.